Alright, continuing through our quotient rule examples here, and I want to look at one more. This is y equals 2x plus 3 cubed over 4 minus 5x to the fourth. And again, when we have a polynomial like this, even raised to a power, on the top and the bottom, we get some interesting simplification going on. So here's the solution. Y primed is going to be low d high, so let's do that. Low is 4 minus 5x to the fourth times the derivative of the top here. And we'll apply the power rule and the chain rule. So that will be 3 times 2x plus 3 squared times the derivative of the inner function, which will be simply 2. So that's low d high, what we have there. Now we do minus high d low. So high is 2x plus 3 cubed times the derivative of the bottom. And again, we apply the power rule and the chain rule. So that's 4 times 4 minus 5x cubed times the derivative of the inner function, which will be negative 5. And all of that is over the denominator squared. So that would be 4 minus 5x to the power of 8. Now, notice that we have a 4 minus 5x to the power of 4 here and a 4 minus 5x to the power of 3. So we can factor out a 4 minus 5x to the power of 3 and cancel it with some of those 4 minus 5x's down there. So let's do that. When we do that, we get y primed. So let's see what happens when we factor out a 4 minus 5x cubed from this term. Okay, we're left with the 3 times the 2, which is a 6. So let's write that as our coefficient. And we're left with a single 4 minus 5x, and we're left with the 2x plus 3 squared. Okay, now let's factor a 4 minus 5x cubed out of this term. We have our minus sign, and you see the negative 5 and the negative 4 give me a minus 20. So minus a negative 20 makes this negative sign into a plus sign, and we have 20 times 2x plus 3 cubed, and we factored out this entire 4x minus 5 cubed. And I'm not writing it because it's about to cancel out with this down here. Whoops. With this down here in the denominator. So after it factors out and cancels, we're left with 4 minus 5x to the fifth. Now, unfortunately, we're not done. There's more that can be factored out here. You might have noticed 2x plus 3 squared and a 2x plus 3 cubed. So let's get that out. And what's left will actually simplify. So I'm going to factor out the 2x plus 3 squared, and that leaves me with 6 times 4 minus 5x plus 20 times 2x plus 3. And of course, all this is all still over 4 minus 5x to the fifth. Now, we're really done with the calculus here. We're just doing algebra to simplify this. And we end up here with 2x plus 3 squared. And if we distribute the 6, we get 24 minus 30x. And over here we distribute the 20 and we get 40x plus 60. And all this is still over 4 minus 5x to the fifth. And then we'll just go one more step to simplify this. You can see our 24 and our 60 will get combined. And the negative 30 and the 40 will get combined. And so we'll have this 2x plus 3 squared. And notice that all of these coefficients are even. So I can factor out a 2 there. So I'll go ahead and do that. I'll put the 2 out front. And over here we're left with a 24 and a 60 gives me a 84. And after I factor out the 2, that's a 42. And this negative 30 and the 40 give me a 10x And after I factor out the 2, that's a 5x. So that becomes a 5x plus 42 over 4 minus 5x to the 5th. And then we're done. And the reason for factoring it out is, one, it's, as I was saying earlier, it's important to be able to recognize that an answer can take multiple forms. But also, things are typically easier to deal with in factored form. And so if you can factor it and simplify it, then wherever you might need to go from there is usually easier from that point on.